Hello everyone, my name is Johan Risandi from Marine Research Center. On behalf of our team, I would like to share our investigation on the increase of mean water level that is induced by wave breaking or the so-called wave setup across the north region of West Java. The presentation will be divided into some sections. Firstly, I will be shortly talking about the background and the objective of the research. Secondly, the description of the study area and the way the data was analyzed will be discussed and followed by the explanation of the result and discussion. In the end, I will summarize the talk and wrap up the conclusion. As we know, flooding is one of the most common hazards in coastal area, although many factors impacting the flood, for example heavy rain, but in this talk we concern on the flooding caused by the increase of seawater level that comes frequently. A study reveals that the loss due to the flooding could be 20% of world GDP by the end of 21st century. So what about in Indonesia? Well, in many places in Indonesia, coastal flooding also caused severe impact on the economy. For example, as we can see in this picture, where water blocked all of the access, slowing down the activities. I haven't got any proven reference on the total loss due to this hazard for the whole country, Indonesia, but I found some literature on some region, for example in Jakarta or Semarang, that it costs billion rupiah per year. So, what is the cause of coastal flooding? There are several factors contribute to the increase of water level causing flooding. In general, we could identify three main sources. The total water level is firstly caused by longer-term sea level increase for more than, let's say, 6 hours. That is the astronomic tides and non-tides parameters, for example, La Nina or other regional forcing like Lewin current in Australia. The second comes from storm surge that's caused by low barometric pressure or direct wind stress resulting wind setup. The third is wave-related contribution, namely low-frequency modulation or infragravity waves with period of 25 to 300 seconds, as well as the swash exertion in coastline due to the incident waves, as well as again because of the IG waves. And the last will be, which will be the focus on this talk, is the mean wave setup. That's basically an increase of mean water level due to the wave breaking within surf zone that push water landward. And wave setups depends on the beach slope and breaking condition. So a question arises is that why the topic is so interesting. Firstly, wave setup plays important role to coastal inundation. Therefore, to know how much the contribution to total water level in coastal region is pretty interesting. Secondly, in Indonesia, the study of wave setup contribution to total water level is rarely discussed. Most study, as I know, is limited to water level increase due to tides. Hence, the main objective of this research is to investigate the wave setup fluctuation at the north coast of West Java. The study area is located in Cirebon region, which is located between Indramayu and Losari, Central Java, as we can see inside the red box. Similar to other coastal area within Java Island, the region also experienced frequent coastal flooding that in particular month, the flooding become more severe. For this purpose, we use Delphi wave with numerical domain of study span between Losari to Indramayu as we can see inside the picture. We also use curvilinear grid that cover around how many is it? 2,500 kilometers square with variable grid sizes. The wave forcing as the input was set into single wave condition with um, significant wave of 2.2 and peak period of 6.8 seconds that propagates from three main directions, that is northeast, north, and northwest, representing what is happening uh, in the study area. In addition, wind forcing was also uniformly imposed within the offshore domain with a single speed of 8 centimeters, and the main direction of the waves are parallel to the direction of wave forcing. Wave setup, in general, basically the difference between offshore and nearshore water level. In Delft 3D, it was calculated from as a function of wave force and hydrostatic pressure, in which uh, the setup on the offshore boundary is assumed to be zero. The result of wave model for three different scenarios are shown here. We can see that the nearshore of Cirebon was the roughest when the wave traveled from northeast, which is in the left side of the slide. It also represents what's happening during the east monsoon. In contrast, at a similar wave condition, but when the wave travel from west, the nearshore of the study area uh, was much more calm, and it represents the condition during west monsoon. And the condition is expected because of the domain is sheltered by the land on the west part of the uh, of the model that block the wave generation, as we can see on the yellow circle on the right figures. Interestingly, when the wave come from the north, even though the north boundary, as we can see, is open sea, the waves near the shoreline was relatively calm. This because of mega sandbar located offshore within the yellow circle on the right images, that in which the mega sandbar dissipate most of the wave energy before reaching the coastline, and it creates some semi-protected system from the excessive waves, except when the waves travel from the east. The sandbar here, the mega sandbar, is possibly developed from river discharge, which is located nearby uh, the sandbar, and the result of longshore drift during wet season. In this slide, we shows the resulting setup for three different wave scenario, which are proportional to the model wave height. The setup, the maximum setup for these three models occurred during east monsoon, with the height of setup is 15 centimeters, and as we expected, the minimum setup occurred during west monsoon. Among three models, the setup was relatively higher at the area with steeper bottom profiles, as we can see here on the red circles. And from this result, we could conclude that the setup is not too significant, because it was only around 15 centimeters that occurred during east monsoon. And there are two possible reasons for that. Firstly is due to weak offshore wave energy that occurred in Java Sea, compared to other area like Indian Ocean with maybe 5 to 6 meter wave height. And the second is due to the flat bottom profile of study area. However, the combination of the setup with other forcing, for example tides and other regional forcing, the setup could give severe flooding to the low-lying area, like we can see in the following slide here. As shown here, flooding has caused inundation on stream ponds and housing nearby the coastline. Specific to this, the right images, we took a peek the actual condition when we did the survey there, and considering the climate change and sea level rise issue, the contribution of waste setup to flooding will be more in the upcoming years. In summary, the model showed the wave patterns across the study area are mainly influenced by the bottom profile and wave directions. During each season, the nearshore wave energy was higher because of less obstacle. Meanwhile, the wave propagation from the other directions saw larger dissipation by shallower region that is sandbar and the inland on the west part of the model domain. As a result, the setup was also higher during its monsoon, with the maximum of the setup around 15 centimeters at the area with steeper profile. Although the setup seemed to be insignificant, there is 15 centimeter. The contribution of the setup with other forcing like tides and, for example, the IG waves and the wind setup, Cirebon area with low-lying elevation is still vulnerable to flooding. Okay, that's all my presentation. Stay safe, and thank you very much for watching this video.